Hello there, Math 126 fans. Going to do some polar graphing. Just mostly what we're trying to do here is get a feel for what it means to plot points in polar. So that's how I want you to interpret these. In the case of doing your homework, they're going to give you multiple graphs, and if you graph the intercepts, you're going to know immediately which one of the four graphs it is. So I'll explain that here. But let's just do a few examples. And I may do one or two of these in lecture, but I won't be able to do them all, so I thought I would do three quick examples here, and we'll show some visuals. So let's say I want to graph this. This ultimately represents your distance from the origin as you rotate. So that's how we think about it. This is the distance from the origin. The only catch is if it's negative, you're going backwards. But in this case, it's never going to be negative because sine is between -1 and 1. It is going to be 0 precisely when sine is -1. Okay, so here we go. We're just going to plot some points directly, and the main points we're going to plot is this. So we're going to plug in 0, we're going to plug in pi over 2. These are values we should know. If you don't know what sine of 0 is, you might want to bring your unit circle along with you as you're doing the homework. So let's go. So they're sitting here. There's sine of 0. It's 0. Here's sine of pi over 2. It's 1. Here's sine of pi. It's 0. Here's sine of 3 pi over 2, -1. So anyways, that's what's going to be in this spot. So first is going to be 0. So you're going to get 2 times 1 plus 0. So this is going to be 2. And then we'll change this to a 1. So it's going to be 2 plus 2 times 2. So it's going to be 4. And we can just plot these, but let's do it. Let's keep going. I like to fill in the first couple of values. So then it's going to be 0. So this is going to be 2. And then lastly, what do we have? 3 pi over 2 is going to be -1. So it's going to be 0. And then it's going to repeat. 2. So basically what I've learned there is that it goes from 2 to 4 to 2 to 0 to 2. Okay, so what do we do? Well, now I can make a little scale on here. So let's do that, meaning if I'm looking in this direction, it's 2. So maybe I'll make this 2 just to sort of fill the space. So that's 2, which means the outer edge will be 4. Okay, then when I'm looking up, I want it to be 4, so that's going to be here. So I'm calling that 1, I'm calling that 2. I'm calling that 2, and that 4. Okay, and then I will plot the next point, which is 2. So I'm looking this way. So this, like I said, this mostly just gets you used to. So when you're doing a homework question, if only one of the graph hits those 3 points, then you're done. All right, last one. When we're facing straight down, 3 pi over 2, we're at the origin. Those are the 4 points that our curve goes through. So again, if you're doing homework, those are the intercepts. So that's why I always start with those, because those help kind of fix us in space. Between those values, it curves in some way. If you want to fill it in more detail, you have to actually just plug in more values. So the next values I usually plug in are things like pi over 4, 3 pi over 4, and so on. And those are values that you can sort of get, but you might want a calculator at that point. So I'm just going to connect them in a way that, in this case, it's never negative. It is 0 for a moment, but I'm going to spiral in some way. If you wanted to be more precise, you'd have to plot some points. And you could say a little bit about the value, the fact that I know sine goes from 0 to 1 in this sort of continuous way, and it comes down. It's going to be positive, but it gets closer and closer to 0 right at this moment, and then it gets bigger. And that's called a cardioid, which means heart. That's it. That's how we graph, but the main thing I wanted you to see is those intercepts. So we're going to come around like this, around like this. So the goal in the homework is get you to practice plotting intercepts and thinking a little bit in terms of distance. Now, at any point along the way, this distance from the origin is what r represents. And in this case, that would be at pi over 4. So that's what this represents, is that distance. All right, let's show you a quick visual. This is it using a grapher. If I go to angle 0, r is 2, like we saw. You can see mine is a little more squished. So now let's go forward. Oops, I have it going way too fast. So let's slow it way down. Let's go back. So r is getting bigger. R is getting bigger. Somewhere in there, and you're at pi over 2. And at some point, you're pointing straight up, and it's 4. It's rounded, so that's why it got there sooner. So straight up is 4. Then if we keep going, we're going to eventually be at pi. You can see it's getting smaller. And then it hits 2. And then it gets smaller and smaller and smaller to get to its smallest value, which is 0. When r is 0, you're always at the origin. And then we're going to go back out. So that's how Polar is telling you. Polar is telling you how far you are from the origin. All right, let's try it again with another one. So cardioid is one common example. Another common example is this thing we call a rose. So again, my goal here is mostly for you to practice plotting intercepts. We can bring our unit circle along for the ride here if we don't know our values very well. But the values I'd be computing are what happens when I plug in 0 here. What happens when I plug in pi over 2 here? What happens when I plug in pi here? And we want to know those. So we're talking about cosine now. So cosine of 0 is 1. So this is going to end up being 2 because it's 2 times 1. And then it's going to be 3 pi over 2. That's what all that is together. So I need this coordinate, which is 0. So it's going to be 0. And then it's going to be 3 pi. Now, where is 3 pi? Well, this is pi. This is 2 pi. 3 pi is back over here. So the unit circle helps me a lot here. So that's -1. This becomes -2. And lastly, what do I get when I plug in 2 cosine of 3 times 3 pi over 2? That's 9 pi over 2. So what's that going to be? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. 9 pi over 2 is going to be looking up. It's going to be 0. There's a lot of work to just say it was 0. Okay, so that's it. And then it does repeat because 2 pi gives 6 pi and you're back here. So this is not going to give us as much information as the last one, because all it's saying is when you look this way, you get 2. So let's call the edge 2, since that's the biggest we can get. When I'm looking up, we get 0. So when I'm looking this way, I get 0. So we've plotted those two intercepts. When I'm looking this way, I'm getting -2. So I'm back over here at this point. When I'm looking down, I'm at 0. So that didn't help me that much. It gave me these 2 points. Now, if I'm just selecting from some homework questions, and there's homework questions that do this, you would immediately rule them out because they hit points that this doesn't hit. All right, let's keep going. So at that point, you would plot a few more points. Now, the other thing you can do is figure out when r is 0. And r is going to be 0 many times in this problem, because cosine is going to be positive, negative, positive, negative. So the other thing you can do to help you graph is find when r is 0, and that would be when cosine is 0. And when is cosine 0? Cosine is 0 here, and it repeats. So I'll grab my unit circle. See, helping us again. So I would say this is 0 when you are at pi over 2, and when you're at 3 pi over 2, and when you're at 5 pi over 2, and when you're at 7 pi over 2. And then I would divide each of those by 3, And you see what you're going to get. You're going to get pi over 6. So this is actually going to be r equals 0. You're going to get pi over 2, which is 0. We already knew that. Next one, you're going to get 5 pi over 6. So that's 0. So interesting. These are actually the moments when you're switching from positive to negative. So from here to pi over 6, which is here, you're going to be positive. So you're going to get closer and closer. And then you're going to hit right there. And then you're going to be negative. And you're going to be, so that means you're going to be facing this way, but plotting over here. So that's what happens. And then when you're looking up, you're back at the origin. And so you get some interesting behavior. So anyways, you come over here. And I think at this point, I'll show you. I wanted to give you this taste of what this would look like. So far we've talked about this distance. We've plotted this value, but it really would be nice to have the next value. Maybe I should plot it. Let's compute it. So let's do 2 cosine of 3 times pi over 4. And this is kind of where it starts to become not as clean, but I know the value. 3 pi over 4 is right here. The x-coordinate is cosine, so you get 2 times negative root 2 over 2, which is negative root 2. So this is negative root 2. So I'm facing this way. I'm back here at 1 point something. And when I'm facing up, we're back at 0. So somehow I go around, I come back, and I end up back at 0 right there. I did a bad job. It should go all the way out. Then I start facing this way and I get positive numbers again. And I've done a bad job here. It comes out. It comes in. And then it goes through here. And then it repeats. And you get this rows behavior. Let me show you that one. So here's this. That's it. Again, we're not expecting you to be an expert on graphing. I just wanted to give you a little taste. Okay, so when you put in 0, you get 2. And then it gets smaller and smaller and smaller. And then that angle, when it's 0, that's pi over 6. That's the first time. And then we're facing, so I drew a little dotted line so you could see the direction we're facing. And we're getting negative values, negative values, negative values until you're looking straight up, and then you're back at 0. Then you get positive values, positive values, positive values, and then you get negative values. So at this moment, the first time we do a full sort of circuit of the rows is actually when we've gotten to pi. So that's kind of interesting. And then it comes down. We go through it again. So now let's animate it here. See what happens. So this is the weird behavior you can get if we allow R to be negative. Again, we're not expecting to be an expert on this. We're not taking enough time for that to happen. But we are getting you to learn to plot a few points and introducing you to some of the things that can happen in polar. The main use of polar is for working with circles. But let's do one more, and we'll finish with that. So last one, this is actually part of a homework question. It's 2 different curves. So let's play this game. So a comment about this one is, since they're saying it's a circle, I would be inclined to try to not eliminate the parameter, but convert. The tools to convert are these. Cosine of theta is x over r. Sine of theta is y over r. So if you want a mechanical technique, you replace cosine with whatever it is in terms of x and r. There's this 3 that was there. Then you rearrange. You get r squared is 3x. And then you get x squared plus y squared is 3x. And that is indeed a circle. And we can complete the square. Half the middle is 3 over 2. We square, we get 9/4. We add that to both sides. And then it becomes x minus 3/2 squared plus y squared is 9/4. So we get a circle centered at 3/2, wherever that is. So let's call this outer edge 3. So 3/2 is right in the middle there. And the radius is 3/2. So it actually looks like this. It's this circle. So it's a circle not centered at the origin. That's why it's more complicated. Then we have this cardioid. So let's plot some points. When you plug in a 0, cosine of 0 is 1, so this is 2. When you plug in a pi over 2, cosine of pi over 2 is 0, so this is a 1. You plug in a pi, cosine of pi is -1, so you get a 0. See how it's you really need to know some values here. If you don't know them, you bring your unit circle along. 3 pi over 2, the value is 0, so you get a 1, and then it repeats. So this one, when I'm facing this way, it's a 2. So 2 is, I made it weird how I labeled these, but 2 is somewhere in here. When I'm looking up, it's 1. This is 1. 1 is like here. And then it's 0, and it actually spirals like this. It's another cardioid, just turned slightly. Heart. And one of your homework questions asks you to consider this area. That one always gets students. Okay, so let me show you a visual of that one. So here it is. I've labeled the 2. So initially, the cardioid is at 2, and the outer radius is 3. And I'm going to start to rotate. So there I'm just labeling in between them, 2 to 2.9. And you eventually get to this one point where they meet. You might have to find that angle in one of the problems. And then we're between them. So you can see I'll get really big here. We're between the two graphs. Between the two graphs, right up until here. Then something sort of interesting happens if you were trying to think about between them, because the red graph starts to be negative. And that's what confuses students on this problem. So all students, when they do this problem in the next section, they get it wrong because they assume that they're supposed to be going between the two curves. But if you're only considering this piece over here, it actually has nothing to do with the circle. So it's the only problem in the homework that's like this, that actually has it where you have to split it up. But you'll know what I mean in the next section. So the goal was just to plot intercepts. I hope you realize that, okay, if you want to get a sense of a polar curve, you've never seen it before, this is what you do. And those are the different directions here. You plot those points. That's your starting place to kind of get you oriented. You'd have to plot more points to connect. I'll probably make a separate video where I talk about different sorts of curves, but that's enough to accomplish what you need in that homework set. All right, hope that helps.